All right, so the last thing I'm going to do here is go through an example of a two-sample t-test that is a little more quick and to the point. So I'm not going to be describing everything about why I'm doing what I'm doing. I'm just going to go through the steps. So in this example, we're going to look to see whether defendants in one county are sentenced differently than defendants in another county for the same offenses. So we'll say we're looking at drug offenses. So we'll say we have one county where we have a sample size of 150. So we're looking at 150 people from this county. We have a sample mean of 10.3 years. And we have a sample standard deviation of 4.1 years. In our second county, we have a sample size of 120, a sample mean of 6.5 years, and a sample standard deviation of 3.8 years. So, and our question is, are defendants from County 1 and County 2 sentenced differently? So when we're doing a two-sample t-test, we're going to start by finding our difference in sample means, because that's the thing we're focusing on. We want to know if our difference in sample means is reasonable to get, assuming that there is no difference between the sample means and the population. So our difference in sample means here, our x bar 1 minus x bar 2 is going to be given by 10.3 years minus 6.5 years. So we have 10.3 here, 6.5 here. And that's going to come out to 3.8 years. So again, the question that we're going to be asking is a difference of 3.8 years between these samples big enough to say that people are getting different sentences for the same crime in these two counties? So step 1. To answer this question, first we're going to write hypotheses. Hypotheses for a two-mean t-test are always going to have the same format. So our hypothesis, our null hypothesis here is going to be that the sample means are the same, which we can also write out as saying that the difference between the sample means is equal to 0. Our alternative hypothesis is the opposite of that. And so we're going to say that the population sample means aren't 0. In other words, our null hypothesis says that in County 1 and County 2, overall, everybody's getting the same sentences. And our alternative hypothesis says that County 1 and County 2 are sentencing people are getting different sentences. Step 2. So step 2 in a hypothesis test is to calculate or find a test statistic. The t-value, or the t-statistic, is the test statistic that we find for a t-test. So here we're going to be calculating our t-statistic for a difference in sample means. The equation for calculating a t-statistic for a difference in sample means is going to look like this, where we have our first sample mean, our second sample mean, and then the standard error for the sampling distribution. As I said before, I'm not going to ask you guys to calculate this, I'm just going to tell you what it is. So here we're going to say that you can assume the standard error value, so s sub x bar 1 minus x bar 2, we're going to say that's equal to 0.486. So now we can just plug stuff in here to find our test statistic. So our sample mean 1 is going to be 10.3. So people in county number 1 are sentenced to an average of 10.3 years for a drug offense. In our second county, we have a sample mean of 6.5 years. So in our sample from county 2, people are sentenced to an average of 6.5 years for a drug offense. Again, these are both values coming from the samples. The standard error for the sampling distribution is calculated based on the information from these samples, but you don't have to calculate it, so instead we're just going to plug in the value, which is 0.486. From here we can do our subtraction and our division, and this should come out to a value of 7.819. So that is our test statistic. Finally, step 3, just to decide whether to reject the null hypothesis. Here we're going to be looking at the p-value. And this is something that I also give to you, and we'll say that for a t-value of 7.819, p is less than 0.0001. So remember, a p-value can be either a specific number, or if it's small enough, we're just going to say it's less than some really small number. So what this tells us is that there is less than a 0.01% chance that we would see sample means as different as 10.3 and 6.5 in these two counties if, in fact, people were receiving the same sentences for a drug offense in these two counties. And so we can look at our p-value and our alpha level to decide whether to reject the null hypothesis. In this case, we know our p-value is less than 0.001, but I'm just going to write 0.001 here. So we know it's even less than this, so if our alpha level is bigger than this number, we know we can reject the null hypothesis. Our alpha level, which I didn't actually write on the top here, but we're going to say that we're going to use an alpha level of 0.05. So I'm going to put an alpha level on the top here, so if you look at the notes version of this that's as a PDF, it'll at least be in the right place at the right time. But we're going to say we're going to use an alpha level of 0.05. So we're going to decide that if there's a 5% chance or less that these two numbers came from populations with the same mean, we'll reject the null hypothesis. So this has to happen, 5% of the time or less for us to decide it's too unlikely for we have to decide that it's too unlikely that these numbers came from populations with the same mean. And that threshold of too unlikely is if we get numbers this far apart from each other only 5% of the time or less. Well, as I just said, our calculation showed us that we would get numbers this far apart from each other 0.01% of the time or less if the population means really were the same. So our p-value is less than our alpha value, and this means that we can reject the null hypothesis. In other words, we have evidence that the true sentences in the populations here, so sentences given out in County 1 and sentences given out in County 2, are actually different from each other. Because the sample means are too far apart to have come from populations that had the same sample mean. And you could also say that the difference between your samples, or your sample means, is statistically significant. All right, and that's it. You are done with your hypothesis test here. And it's, again, used these samples to tell us information about what's likely to be true in the population. And with that, I'm going to sign off here, and I hope you guys have a great week.